Good morning all. Today we'll see a lecture on block convolution using DFT. Now when we go for a linear convolution for a long sequence, we require a large memory, so the processing time will be the more. So what we do in block convolutions, we divide a long sequence into a small block or a small section, and then we'll convolve this section or block sequence with a finite impulse signal, and will get desired output by using the appropriate method. That is the meaning of block convolutions. Now block convolutions can be performed in two ways. One is known as overlap save method, and second is known as overlap add method. So what we do in overlap save method, so let me take the pointer option. So what we do in overlap save method, first we find the m minus 1. Okay, so m minus 1 is nothing but the samples of impulse response sequence, that is h of n, that is equals to capital M. Capital M is what? Capital M is equals to samples of impulse response sequence h of n. So first we calculate m minus 1. After calculating m minus 1, we perform a overlap save method. Similarly for overlap add method. So we will see detail in the upcoming question. Now the question is what? Find linear convolution using overlap add and overlap save method for the following sequences. Sequence of x of n is given and the sequence of h of n is given. So before finding the linear convolution using overlap save method and overlap add method, we have to calculate the number of samples in the output sequence for a linear convolution is equals to samples of x of n plus samples of h of n minus 1. So here 3, 3, 6, 3, 9, 12. 12 plus 3, 15. So 12 plus 3, 15 minus 1. That means the output in the output sequence will be having what samples? Will be having the 14 samples. So here samples of x of n is denoted as capital L, and the samples of h of n is denoted as capital M. Okay, samples of x of n is equals to capital L, and the samples of h of n is equals to capital M. Now after x of n and h of n, we need to calculate value of capital N. So capital N indicates the block length or the section length. Now how to calculate this capital N? There are two methods. First method is what? If x of n, samples of x of n divided by samples of h of n, you divide samples of x of n sequence by h of n sequence, will be getting the some number. So here 12 by 3, so that is equals to 4. So this is my first method. If we are getting the answer in point, so don't consider if it is 2 point something, if it is 3 point something, if it is 4 point something, so don't consider this method. And the second, this is your first method, and the second method is what? So second method is capital N is equals to, that means block length or section length is equals to samples of h of n, that is equals to capital N. Capital M is what? Samples of h of n plus 1. You consider like this, plus 1. So here also we are getting as 4, and here also we are getting as 4. In between these two method, you can use the first method or second method. If first method is applicable, go for first method. If this is not applicable, go for the second method. Now so let's consider here the block length, or if first is not applying, second is not applicable, so you consider the block length as you want. Now the capital N is equals to 4, the length of h of n capital M is equals to 3, so m minus 1 is equals to 2. Now we will be doing method. So in overlap save method, what we have to do, we have to add m minus 1 0. For overlap save method, we have to add m minus 1 0 before and at the end of x of n sequence. We need to add m minus 1 0 before and at the end of the x of n sequence. So here the value of m minus 1 is equals to 2. So we'll be adding 2 0 before and 2 0 after the sequence of x of n. So we'll be having modified sequence as, so here we have added 0 0, 2 zeros before and 2 0 at the end. Now after the modified sequence, we have to divide this sequence into a small block or small section, and the length of a small block or small sections we have taken capital N is equals to 4. That means each block or each section will have number of samples is equals to 4. So we'll be having sequence of x1n. Now we have to divide. So sequence of x1n, initially you take these 4 samples because the block length is of 4. So we have taken the initial 4 samples. Now to have a x2 of n, so we need to take the last m minus 1 samples of a previous sequence. So previous sequence is x1n. So last m minus 1 samples means of 1 2. So 1 2 will be the initial samples of the next sequence. So next sequence will be having 1 2, and the next 2 samples we have to take from the sequence of x of n minus 1 2. Okay. So initially we need to take the first 4 samples because the block length is of 4. So we have taken 0 0 1 2. Then m minus 1 samples of a last sequence. So m minus 1 samples of a last, and last sequence, what last sequence is x1n, and the last samples 1 2. So 1 and 2 will be here. It will be the initial samples of the next sequence, and again we require 2 samples to become a length of block as 4. Then similarly for x3n, again we have taken minus 1 2, then 3 2, then 3 minus 2 will be having 3 minus 1, then 3 minus 1 will be having 1 1. Then for x6 of n, 1 1 2 1, and x7 of n, last sequence is 2 minus 1 0 0. Now after that we have to consider the impulse response sequence, finite length of impulse sequence. So here the sequence of h of n having the 3 samples, okay, but the block length we have considered it is of 4 samples. So we have to make the sequence of h of n also of 4 samples. So to make it is of 4, we need to add 1 0. So here the sequence of h of n is given as 1 2 3, and we need to add 1 0 because we have considered the block length is of 4 samples. Now after that we have to use the convolution method. So for the convolution method we have to convolve the sequence as y1n. It is circular convolution with x1n and h of n. In similar way we have to do for y1n, y2n up to y7n. We need to calculate all this value. Okay. So y1n is equals to x1n circular convolve with h of n. So we have taken this as a sequence. Okay, 0 0 1 1, then 2 will be shifted here, then 0 0 0. This method we have seen in the last lecture. So here it is 1, then 2, then 0, then 0. So the size of sequence is 4 samples. So the matrix will also is equals to 4 by 4, and here you need to take the sequence of h of n. Okay, then you cross multiply row into column, row into column, row into column, row into column. So we'll be getting the answer as 7 6 1 4. So we have got the answer for y1n. Similarly we can do for y2n. Again you take the same sequence. So sequence of x2n is 1 2 minus 1 2. Then you perform the circular convolution between x2n and h of n. We'll be getting the answer for y2n. Similarly for y3n, also we have to calculate for y4n, y5n and y6n. So and the last sequence is what? The last sequence is for y7 of n. So from y1n to y7 of n we need to calculate, and after calculating y7 of n, so this is the last sequence y7 of n. After calculating y7 of n, we have to do the following step. So the step is what? The final output y of n is obtained by removing m minus 1 samples, so the value of m minus 1 samples is equals to 2 from each output block, and then by connecting all output blocks one after other. So what is the meaning of this statement? So let me show you here. So these are my outputs y1 to y7s. So what we have to do, we have to remove initial m minus 1 samples. So m minus 1 samples is equal to, so we'll be removing this initial m minus 1 samples from each output block, okay, and the remaining 2 samples we have to consider one after other. That means the output equation of y of n is equals to 1 minus 4 6 6 4 10 2 minus 13 minus 10 0 7 6 4 minus 3. So we'll be getting output like this, y of n, as we have removed the initial m minus 1 samples. If the value of m minus 1, in case suppose if it is 3, so we'll be removing 3 samples, okay. If it is 1, so we'll be removing 1 samples, it depends, okay. So here the value of capital M minus 1 is equals to 2 samples. So now as you consider the value of the samples of the samples in the output sequence is equals to what? The samples in the output sequence is equals to y of n is equals to 14. So if you calculate 1 2 3 4 5 6 7 8 9 10 11 12 13 14, so we'll be getting the 14 samples, okay. Now we'll see the next method. So the next method is known as overlap add method. In overlap add method, what we do, so each block is obtained by adding m minus 1 0 at the end. So the length, the block length is of 4 samples. So in that block length we have to add m minus 1 0 at the end of each sequence or each length, each block or each section. So this is the original sequence of x of n. Capital N is equals to, that means block length or the section length is equals to 4, and in the block, each block length we have to add what? We need to add m minus 1 0, that means 2 0 we need to add. So initially we will be taking these 2 samples and we have to add 2 0, so it will becomes the length of a block of 4 samples. So 1 2 0 0, then the next sample is minus 1 2 0 0, then 3 minus 2 0 0, then next one is what? 3 minus 1 0 0, 1 1 0 0, 2 minus 1 0 0. So here it is not minus 0, here it is only 0, 2 minus 1 0 0. Now after that you apply the same method, circular convolution between x1n and h of n, you will be getting the y1 of n. So you apply the same method here from y1n to y6n. So we will be getting the output for y1n as sequence of x1n circular convolution with h of n. Then 1 2 0 0, then same here, then 0 is shifted here, okay, then 1 2 0, then again 0 0 1 2, then again it is 2 0 0 and 1. So number of samples in the each block of 4, so the matrix size also 4 by 4. We'll be getting y1n. Similarly you find for y2n, y3n, y4n, y5n and y6n. So these are the outputs for y2n, for y3n, for y4n and for y5n. Now the last is what? Last one is y6n, x6 of n circular convolution with h of n, y6 of n. Will be getting the output as 2 3 4 minus 3. Now after that, for overlap add method, what we have to do, first initially we will be taking these samples. So the final output is obtained by overlapping and adding individual outputs. So I have the sequence of y1n, and what number of samples are overlapped and added from the individual outputs, that is equals to the m minus 1. So the m minus 1 samples are going to overlap and we have to add. So what is the value of m minus 1? So the value of m minus 1 is equals to So m minus 1 samples of a previous sequence will be added to the initial samples of the next sequence. So I have taken y1n, y2n, y3n, y4n, y5n and y6n. So the last two samples, that means m minus 1 samples of the last sequence, it is going to add an overlap with initial two samples of the next sequence. So here also, so addition will be taking from these two overlap. So this samples 7 is overlapping with minus 1, 6 is overlapping with 0, 1 is overlapping with 3, overlap and then add, 6 is overlapping with 4, 5 is overlapping with 3, minus 3, minus 6 is overlapping with minus 7, minus 11 is overlapping with 1, minus 3 is overlapping with 3, 5 is overlapping with 2 and 3 is overlapping with 3. Then we need to add. So after this addition, so 7 minus 1, it becomes 6. So here also 6, 4, 10, then here it is 2, minus 13, minus 10, 0, 7, 6. So the final output it becomes 1, 4. Initially it is 1, 4, then here it is addition, that means 6, 6, 4, 10, 2, minus 13, minus 10, 0, 7, 6, and these are the last two samples, 4 minus 3. And what we got the output for overlap save method, it will remain same for the overlap add method. In this way we can perform the linear convolution using overlap add and overlap save method. We'll see the next question. So here the question is x of n is equals to the sequence is given and h of n sequence is given. So using overlap add method and save method, find linear convolution. So length of L is known, 3, 3, 6 and 8. So the length of L is equals to 8 here, and the length of h of n, that means capital M, is equals to 3 here. So when you divide 3 by 8, so the answer will get in points. So will not consider this. So will not consider the first method, will be considering second method. So second method is what? The samples of capital N is equals to samples of h of n, that is equals to m. So the m is equals to what? 3 plus 1. So we'll be considering capital N is equals to 4 here. Then after considering capital N, that means each block length is of 4 samples. Then you perform overlap add method and overlap save method, will be getting this as the output. So you please check, you will get this as the output. So as you consider here, the number of samples in the output sequence is equals to samples of x of n plus samples of h of n minus 1. So 8 plus 3 minus 1, so we'll be getting the answer as 10. So 3, 3, 6, 3, 9 and 10. So it is correct. So that's it for today's lecture. Thank you very much.